Good morning, everyone. Today we're going to focus on independent and dependent events. So two events are independent when the occurrence of one event does not affect the occurrence of another event. So for example, rolling a dice and spinning a spinner. If I roll a 3, it doesn't necessarily mean it's going to have any effect on my spinner, so they're independent. Two events are dependent when the occurrence of one event does affect the occurrence of another event. So for example, if I have everyone in class and I pick one student to be speaker and another student to be the recorder, obviously if I pick one student to be the speaker, that's going to affect how many students are left to be the recorder. So those would be dependent events. So two events are independent if and only if the probability that both event occurs is the product, which means multiplication, of the probabilities of the event. So for example, the probability of A and B is equal to the probability of A times the probability of B. And equals multiplication. So for example, as part of a board game, you need to spin the spinner, which is divided into 8 equal parts. Find the probability that you get a 5 on the first spin and a number greater than 3 on your second spin. So the probability of getting a 5 and a number greater than 3 would be the probability of getting a 5 times the probability of a number greater than 3. So getting a 5 would be 1 out of 8 because you have a 1 out of 8 chances to get a 5. And then number greater than 3 would be 1, 2, 3, 4, 5. 5 out of 8. And then you multiply them. So 1 over 8 times 5 over 8. Math 1, enter, would be 5 out of 64. And again, you can also just multiply your fractions across. Any questions on that? If so, make sure you Zoom us later. Jill rolls a 6-sided dice. What is the probability she's rolled a 3 given? So given means that this is assumed that she's rolled an odd number. So how many odd numbers are there on a dice? 3. And then she's rolled a 3. So there's 1 3 out of 1, 3, and 5. So it's a 1 out of 3 chance. So that's kind of conditional. So the probability of an event given that another event has already occurred is called a conditional probability. Given that A and B are dependent events, the conditional probability of event B given that an event A has already occurred is defined that P, the probability of B given, that little line just means given A, is the probability of A and B divided by just the probability of A, which is what we did here. If two events A and B are dependent events, then the probability that both events occur is defined as probability of A and B is the probability of A times the probability of B, again, given A. That line just means given. So the table below shows the number of students who are varsity athletes. Find the probability that a student is a varsity athlete given that he or she is a junior. So it's going to be 36 over 36 plus 276. I'm going to use my calculator for this, which would be 312. So 36 divided by 312, math 1, enter, would be 3 out of 26. So find the probability that a test subject stayed healthy, given that he or she used an experimental drug. So healthy and use the drug. So it'd be 800 over 800 plus 160, 1,600. And again, I'm using my calculator for this. Math 1, enter, and you get 1/3. A bag contains 20 $1 bills and 5 $100 bills. So there are 25 bills total, 25 bills total. You randomly draw a bill from the bag and set it aside and randomly draw another bill from the bag. What is the probability that the first bill is 100? So there are 5 100s, and the second bill is 100. So that'd be 4 over 24. Because again, I'm taking one away and not returning it. So it'd be 5 over 24, 5 over 25 times 4 over 24. Math 1, enter, and you get 1 over 30. I'm going to continue this. My videos are leaves. I'll continue this in the next video.